let us start with the next question. For any sets A and B, show that power set of A intersection B is equal to power set of A intersection power set of B. So what is a power set? Power set is set of all the subsets of a set. For example, if I say power set of set A, so if let us say set A is 1 comma 2, then I'll write the subsets of set A, which are empty set, then singleton sets, and then containing both these elements. So if I create a set of all these subsets of this set A, then this set is power set of A. So power set of any set is a set of its subsets. So if you see the elements themselves are sets. Elements themselves are some sets, right? Elements of a power set are themselves sets, right? And what kind of sets are they? They are subsets of the set of which we are taking the power set. I hope this is clear. So let us start. Now, to prove that this set, this is a power set, this is another set, right? So to prove these two sets to be equal, what I need to show is that the set on the left hand side is subset of the set on the right hand side, and vice versa is also true, right? Because if I need to show that set A is equal to set B, then I need to show A is subset of B and B is subset of A. Similarly, I need to show this set is subset of this set and this set is subset of this set. Now let us start the question. So let me take any general element, right? Why I have taken capital X? Because element of a power set is a set itself. So I have taken this capital X to be one of the elements of this set on the left hand side, which is A intersection B, right? Now this, if this belongs to power set of A intersection B, it means that this is subset of this set written inside the bracket. That means this is subset of A intersection B. You got the idea? Like I got this set, right? If I write its power set, then if I say that this element belongs to this power set, then this has to be a subset of this, because this is the definition of power set, that it is set of subsets of this particular set, right? I hope you understood this, that this capital X will be a subset of A intersection B. Now if it is subset of A intersection B, you will appreciate that it lies somewhere here, its elements. So it is definitely a subset of set A. That implies it is definitely a subset of set A, and it is a subset of set B also, right? This much you understood. Now if this set is subset of set A, right, will it be there in power set of A? Of course, it will be present in power set of A as an element, right? If this is subset of A, for example, this is subset of this set, so it belongs to its power set. So X being subset of set A, it will belong to power set of A. And you take care of this and, right? Because these two conditions are true simultaneously. So we can also say that this X belongs to the power set of B also. It belongs to power set of B also. Now if something belongs to power set of A and this power set of B, what it means is that this is acting as an element, right? So this element, that is capital X, is common to this set and this set. That means it belongs to their intersection. That means this belongs to intersection of power set of A and power set of B. Now see, we started with this, that this is a general element which belongs to this power set, and we reached at this conclusion that this element that we started with also belongs to this set. Then we can say that this set, power set of A intersection B, is a subset of intersection of power set of A and power set of B. Right? First thing I have shown you. Now this is half the solution, because we also need to prove vice versa, that this is a subset of this. Right? So we will again start with a general element that belongs to this set. So let us say there is a general element Y which belongs to intersection of power set of A and power set of B. And we know if it belongs to intersection of power set of A and power set of B, then definitely it belongs to power set of A and it also belongs to power set of B, because it is common to both these sets, right? And see, if it belongs to power set of A, then what does it mean? If it belongs to power set of A, then that means this is subset of the set written inside it, right? And this is also subset of this set that is written inside it, right? If it is subset of A as well as subset of B, that means it is subset of A intersection B. You got the idea? So it is subset of A intersection B. And if it is subset of A intersection B, then it will definitely belong to its power set as an element. If it is subset of A intersection B, then it will belong to its power set as an element. What I want to say is, if something is subset of some set, let us say this is subset of this set, then it will belong to the power set of this set, which is what I have written here as my interpretation. So now see, I started with this, that this element belongs to this set, and I reached at this conclusion that this set also belongs to this set. So I can say power set of A intersection power set of B is a subset of power set of A intersection B. So what I have shown you is that this set here is subset of this set, and this set is subset of this set, and it can be only true when these are equal, right? So if A is subset of B and B is subset of A, if and only if A is equal to B, right? This is the condition for equality of sets. Okay, I hope you have carefully listened to each and everything that I have said, and if you have done that, then you would have understood this question. Okay, now look at this example. A market research group conducted a survey of 1000 customers and reported that 720 customers like product A and 450 customers like product B. What is the least number that must have liked both the products? Okay, so what is the least number? Let us say all of these customers like at least one of the products A or B. So if they like at least one of the products A or B, then it will be, or let me write it like this. If let us say I take number of elements in A union B, what will it be equal to? Number of elements in set A plus number of elements in set B minus number of elements in A intersection B. See, the number of customers who like product A is, let us say, this. So I write 720 here. Number of customers who like product B is 450. Let us say I write it here. And what is the least number? It is asking least number, not the exact number, right? That must have liked both the products. So let us keep it like this only. So now what does this least number depend on? It will depend on that the term that I write here, right? Because this and this is fixed. We have written this as 720, this as 450. So in total this is 1170 minus n A intersection B. So now when will it be least? When will it be least? When the number written on this side is maximum, right? Because if you consider this number, let us say you consider this number m, okay? So think about this number, A intersection B, number of elements in A intersection B is equal to 1170 minus this capital M, right? So I need it to be the least, right? The minimum. If it has to be the minimum, this number here has to be the maximum, because I need to subtract it from this, right? And what maximum this number can be? What can this number be? Where will it be maximum, right? What will be the maximum value of this number? It will be maximum if all of these customers are falling under this category, and they will fall under this category if every one of these 1,000 customers like at least one of these products, right? So this was the survey, this was my universal set, okay? But A union B, if A union B is equal to this number, that is A union B itself is a universal set, or the maximum customers that can be there in this A union B will give me the minimum value of this, right, which I require. So M, for this number to be minimum or least, M has to be maximum, which is 1000, and this will give me 170 as my answer, the number of customers, least number of customers who like both the products, okay? Because there are questions where this A union B, number of elements in A union B, is lesser than the universal set. It is generally like that. But it may be possible that all the elements that are there in the universal set are involved in these, right? Or every one of them likes some product or not, likes one of the product, okay? We discussed about it in previous exercise also, that there can be such a scenario, okay? Out of 500 car owners investigated, 400 owned car A. So let us write it like this. Number of people who own car A are 400. 200 owned car B. So let us write it as 200. 50 owned both A and B. So let us write it as A intersection B equals 50. Now, is this data correct? Total number of owners who were investigated are 500. So this is my universal set, okay? There cannot be anything above that, because everything has to be a subset of this universal set. So let me first of all find A union B. It will be equal to sum of these, that is 400 plus 200, and then I'll have to subtract these common elements, so it is equal to 550. See, this universal set, this is the universal set, right? And this is my A union B, right? So A union B has to be, number of elements in A union B has to be less than or equal to the number of elements in universal set. So what I can say mathematically, that number of elements in A union B has to be less than or equal to number of elements in universal set. So the number, what maximum number can be the number of elements in A union B it can be maximum number of elements in universal set, but it cannot go beyond that. Then what is the sense of having a universal set if it can go beyond that? A universal set contains everything that is under discussion, right? So nothing can be bigger than the universal set. So this data is incorrect because this number of elements in A union B is coming out to be greater than number of elements in the universal set, which is not valid, which is not valid. Hence this data that is given in this question is incorrect.